So last class period we discussed how to change the amplitude and the period of your graph. And just as a quick reminder, remember we said if your general equation for sine is y equals a sine bx plus c plus d, the absolute value of this variable up front, that's your amplitude. And same thing for cosine. And for period, remember we said that to figure out the period, you do 2 pi divided by b, this value that's in front of x. Or if you're in degrees, it would be 360 degrees divided by b. Okay? Absolute value of 360 degrees divided by b. Okay, we use absolute value because period can only be positive, just like amplitude can only be positive. Okay, so now we're going to talk about shifting. So shifting up, shifting down, shifting left, and shifting right. So what are phase shifts, vertical shifts, and midlines? A phase shift is the horizontal distance the graph has moved from standard position. So standard position is, for cosine, it looks something like this. Well, imagine if your cosine graph was shifted to the left a little bit, and instead of starting on the y-axis, it shifted to the right a little bit. Okay, well that's a phase shift. Vertical shift. Vertical shift is the vertical distance the graph has moved from standard position. So normally in standard position, your graph for cosine looks something like this. Well, maybe you shift it vertically so that instead of this being the midline, maybe your midline is, up here. And so now your graph looks something like this. And it kind of oscillates up and down around that new midline instead of around the x-axis. So the midline is the equation of the line that bisects the graph horizontally. So question 1, what is the equation of the midline when sine or cosine is in standard position? Well, we've already discussed this. That midline, when it's in standard position, is this blue line that I just drew. It's actually the x-axis, and the equation for the x-axis is y equals 0 because it's a horizontal line. So let's look at how you shift. So vertical shifts and midlines. Vertical shifts are pretty easy to think about. So it says below is the graph of the function y equals sine theta plus 1 on the domain negative 3 pi to positive 3 pi. What is the vertical shift of this function? Well, you can tell that because instead of oscillating around the x-axis, you can see it oscillates around this horizontal line. So the vertical shift is up 1. That horizontal line around which it oscillates has moved up 1 space. So you can write up 1, or you can just write positive 1. What is the equation of the midline? Well, the equation of the midline is now y equals 1. Notice the difference between asking what is the vertical shift and what is the equation for the midline. Equation for midline is a horizontal line. Vertical shift is just a value, one number. So what is the vertical shift of this function? Well, that's going to be negative 2, or you can say down 2. This quantity outside causes it to shift up or shift down, and that should be familiar to you guys from Algebra 2. Remember when you add a number outside of those grouping symbols, that it moves the function up or moves the function down. What is the equation of the midline? Okay, the equation is going to be y equals negative 2. Now it asks you to draw the function y equals cosine theta on this domain. So my period hasn't changed, my amplitude hasn't changed. The only thing that's changed is there's a phase shift. So first thing I'm going to do is I'm going to draw in my increments, and I'm going to do it in radians. So pi over 2, pi, 3 pi over 2, 2 pi, and then, so I got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, now we're at 5 pi over 2, and then 6 pi over 2, which is 3 pi. And that's where I'm going to stop because that's where the problem told me to stop the domain. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, and then negative 3 pi. Now normally your graph starts at 1. However, that's because it oscillates around the x-axis. Well, here there's a vertical shift of 2. So what I'm going to do is I'm going to draw in that midline. I'm going to make a dotted line here. That represents the midline where it's going to oscillate around. My amplitude is 1, so I'm going to go ahead and draw in my function. Its cosine starts one space or 1 unit above the midline. So normally it starts at 1, but because there's a vertical shift here, it's going to start at 3. And then it's going to go to 0, down, up, to 0, well not 0 in this case, 4. Down to the axis, below. So it's going to look something like this. Okay, notice it's oscillating around that line. It still has an amplitude of 1 because it's from the midline, it's a distance 1 to the top and a distance of 1 to the bottom. Okay, connecting. All right, and so that's my function. That's y equals cosine theta plus 2. So it's just been shifted up 2 spaces. Moving on. Question 6. So now it's just asking you, what is the vertical shift and the equation of the midline? So vertical shift is 3. Equation of midline is y equals 3. Here vertical shift is 0. There is no plus anything outside. So that means the midline is y equals 0. It's just the x-axis. Here there's no vertical shift. So y equals 0. And here there's a vertical shift of 2. So y equals 2 is your equation for your midline. Now, phase shift. Phase shift is your shift left and your shift right. So below is the graph of the function y equals cosine of theta plus pi. Now remember back to algebra 2, if you're adding or subtracting inside the grouping symbols, that's what causes your function to move left and right. So when I add pi here, it's actually causing it to shift to the left, because remember adding actually moves to the left. It's causing it to move to the left pi. So normally where my cosine function would look like this, it would start at 1, go here, okay, it would look something like that. What's happened is it's been shifted to the left pi units. Okay, you guys see how that works? It started out here. This is where cosine normally is, but this function has been shifted to the left, like that. Now, how do I know that? Well, just looking at the equation, and this is kind of difficult to see normally, but if we're talking about our function y equals a cosine b theta plus c plus d, your phase shift actually ends up being negative c divided by b. Okay, negative c divided by b. So in this case, my phase shift, I can tell from looking at the functions shifted, phase shift is negative pi, okay, because my c in this case is pi. All right, below is the graph of this function, y equals cosine theta minus pi over 2 on this domain. So again, let me demonstrate. Here's where cosine normally would be. Okay, it would look something like that. This has been shifted to the right pi over 2. So you can see, if I move it to the right pi over 2, there's my cosine function. This is cosine in standard position, and this is cosine shifted to the right pi over 2. So if I use my formula, I know that phase shift is negative c over b. So in this case, b is 1. So phase shift is just negative pi over 2, which is why it ends up being positive pi over 2. Below is the graph of this function, 2 theta minus 2 pi on this domain. What is the phase shift for the function? Okay, well here, this b value of 2, this value of 2 here, this causes the period to change. And in addition to that, this causes a phase shift. So you have a phase shift and a change in period. So that's why you have to divide by your b value. So phase shift is negative c, so negative 2 pi divided by b. So this ends up being 2 pi over 2, which is just pi. So you have a phase shift of pi. And to the right, okay, so that means you're moving to the right pi units. Question 10, so very similar. Again, phase shift is negative c over b. So I'm going to do phase shift equals negative 8 pi, so negative 8 pi divided by 2, so phase shift is negative 4 pi. So it's moving to the left 4 pi units. What is the phase shift for this function? Lots of kind of the same questions, so negative 6 pi divided by 2. So we get phase shift is 6 pi over 2, phase shift is 3 pi. So it's going to take the function and move it to the right 3 pi units. What are the phase shifts for the following functions? There is no phase shift here. Phase shift is negative c over b, so we get negative 0 over 1, which is 0. There's no phase shift. There's also no phase shift here. There's no c value. There's no phase shift. Here, phase shift is negative 3 over 1, so you get positive 3. And then down here we'll get phase shift is negative 6 pi divided by 2/5. Notice that 2 over 5 is the a value, the b value. So phase shift is 6 pi times the reciprocal, sometimes 5 over 2. 6 divided by 2 is 3. 3 times 5 is 15. So you get phase shift of 15 pi. So that means your function's moving to the right 15 pi radians. Okay? So I'm going to come back over here to this worksheet that you guys got, that master sheet. It's kind of a good study sheet. So now we've got phase shift and vertical shift and equation of midline. So the phase shift is negative c over b, left or right. Negative c over b moves it left or right. On the graph, it's a left and right distance shift from the starting point. Your vertical shift is your d value. And remember that we're referring back to this equation up here. So a, b, c, d. It shifts it up or shifts it down. And same thing for cosine. For your equation of your midline, it's always y equals, and whatever the value of d was. Okay, remember the difference between the equation of a midline and the vertical shift. An equation of a midline is y equals whatever. And the vertical shift is just that quantity, that number.